Welcome to week 3 of Business 226. We're going to talk through chapter 5 and chapter 6. Chapter 5 is all about interest rates and the time value of money. There's a spreadsheet on Canvas that has all these formulas into it, and all you need to do is utilize that Excel spreadsheet to do these formulas. So this talk will focus mainly on where to find the information. Chapter 5, we're talking about future value, present value, finding interest in time, annuities, rates of return, and amortization. I'm going to talk real fast, so feel free to pause and rewind here. Timelines, showing the timing of payments. Um, so if you get the payment at the beginning or at the end of a period. $1 lump sum due in 2 years. So that's 2 years. $300, 3-year, $100 or 3-year, $100 ordinary annuity. That means every year, at the end of every year, $100. Or an uneven cash flow stream. You're negative $50, $100 year one, $75 year two, $50 year three. What is the future value of an initial $100 after 3 years if interest rates equals 4%? Finding the future value of a cash flow or series of cash flows is called compounding. Future value can be solved using the step-by-step financial calculator and spreadsheets. Use the spreadsheet. So after 1 year, you have $104. After 2 years, you have $108.16, not $4 anymore, $4.16. And in the third year, you have $112.49, $4.33. Compounding money. That is a very important concept. Solving for future value calculator and Excel methods. Here is what you input into the spreadsheet to get your future value. And that's the formula right there. Present value, you want to know how much you need to invest now to have $100 at the end of 3 years. You have to invest $88.90 at 4% for 3 years to have $100. And here's the Excel sheet again. That's the formula you would input. Solving for interest or for years. Interest a year. What annual interest rate would cause $100 to grow to 119 in 3 years? So how much do we have to get on our money to have $119 if we put $100 in at the beginning? There's the formula right there, and it kicks that out. If sales grow at 10% per year, how long before sales double? 7.3 years. And this shows a really valuable rule. It's called the rule of 72. If you get 10% interest, it's going to take 7.2 years for your money to double. If you get 8% interest, it's going to take 9 years for your money to double, and so on. So basically, you take your years, divide it into the 72, and that's the interest rate that you need to get. Or if you have an interest rate, you can divide it into 72 to get your years. So if you get 2% a year, it would take 36 years for your money to double. So the higher the interest rate, the quicker your money will double. What is the difference between an ordinary annuity and an annuity due? Annuity due just means the payment happens at the first of the year instead of the end of the year. Given a 3-year ordinary annuity of $100 at 4%, $100 payments occur at the end of each period, but there's no present value. The future value is 312.16. So over the course of 3 years at 4%, you wouldn't have $300, three equal payments of 100. You'd have 312.16. And there's the Excel formula. Given a 3-year ordinary annuity of $100 at 4%, $100 payments still occur at the end of each period, but now there's no future value. The present value is 277.51. So that $100, if you wanted to receive $100 at the end of every year, you'd have to invest 277.51 and you would get $100 at the end of each period. And here's the Excel formula. Now, $100 payments occur at the beginning of each period. Look, the amount goes up to 324 because the money's getting invested at the beginning of the period. So it has that whole period to earn interest. And so the interest is earning interest faster. And as you can see, the present value goes up because you would be taking the money out sooner. Excel formula right here. Present value calculation. What is the present value of a 5-year $100 ordinary annuity at 4%? So the present value, the money you would have to put into an account at 4% to get $100 at the end of each period, you'd have to put $445.18 into an account earning 4% to be able to withdraw $100 at the end of every year for 5 years. A 10-year annuity, you'd have to put 811. A 25-year annuity, 1,562. And in perpetuity, 2,500. So the power of compound interest. A 20-year-old student wants to save $5 a day for her retirement. Every day she places $5 in a drawer. At the end of the year, she invests the accumulated savings, 1,825, in a brokerage account that's expected to earn 8%. Over the course of 45 years, 65 minus 20, how much money will she have? If she starts today, she will have $700,000 at the end of 45 years. And that's only $1,825 a year. If you don't start saving until you're 40, now all of a sudden it's 133. That is a huge difference. 20 years, but it's 600,000 almost. That is a huge difference. Start early, just a little bit, $50 a month until you make enough to increase that. Make a huge difference in your savings. The power of compounding money. How much must a 40-year-old deposit annually to catch up? $9,700 versus $1,800 if you had started 20 years earlier. Huge difference. What is the present value of this uneven stream? Well, here, all you have to do is find the present value of these different amounts and then add them up to come up with your present value. That's all it is. You just have to do it different. You have to do each of the formulas, present value of a single amount, 4 times. Super easy. What will the future value of a lump sum be larger or smaller if compounded more often, holding the stated constant? It's going to be larger because the money's compounding more often. So you're earning money on the money. So see, it's 4%. Here, we're just doubling it. So you have to take the time times 2, the interest rate divided by 2, but it's still always going to be more because you're earning interest on the interest. You're making money on your money. So classification of interest rates. Nominal rate, also called the quoted or stated rate, an annual rate that ignores compounding effects. The periodic rate, amount of interest rate charged each period, monthly or quarterly. It's stated on the contract, periods must be given, 4% quarterly or 4% daily, 1 per or 1 nominal, where M is the number of compounding periods per year. M equals 4 for quarterly, M equals 12 for monthly compounding. CDs are monthly, that kind of stuff. Loans are generally daily. Classification of interest rates, effective or equivalent annual rate. Effective annual rate, effective rate. The annual rate of interest actually being earned considering compounding, effective rate for 4%. This is going to go up and up depending on how often you compound it. If it's monthly, see here, the semi-annual interest, it goes up. Whereas if it's just once a year, it's 4%. So the effective rate is 4%. The annual rate was, or the effective rate is 4.4. The importance of effective rates of return. Investments with different compounding intervals provide different effective rates. We just showed that. It could be 4% annually or 4.4% if it's 4.04 if it's semi-annually. So annually see 4%, semi-annually 4.04, quarterly 4.06, daily 4.08. That's a huge difference when you're talking about thousands, millions of dollars. When is each rate used? Well, the nominal rate is written in the contracts quoted by banks and brokers, not used in calculations or shown on timelines. The periodic used in calculations is shown on timelines. And the year used to compare returns on investments with different payments per year, used in calculations when annuity payments don't match compounding periods. So effects of compounding on future value. What is the future value of $100 after 3 years under 4% semi-annually compounding or quarterly compounding? Semi-annual, quarterly. See the difference? I know it's only 6 cents, but imagine if that was 100,000 or $1,000,000. Huge difference starts to happen there. Effective rates versus nominal rate. Can the effective rate ever be equal to the nominal rate? Yeah, but only if it happens once a year. If M is more than 1, effective rate will always be higher. I mean, we show it right there. What's the future value of a 3-year $100 annuity if the quoted interest rate is 4% compounded semi-annually? Payments occur annually, but compounding occurs every 6 months. So we have to use a slightly different. Remember, we double the time, half the interest rate. So the future value is going to be just a little different. And this is the formula that you put into it. 3 years, 4.04, gets the same answer. Find the present value of this 3-year ordinary annuity. Could solve this by discounting each cash flow or use the effective annual rate. Present value, $277.30 is how much you'd have to put in to pull out $100 every year. Loan amortization. Amortization tables are widely used for home mortgages and auto loans, business loans. Basically, you pay a set amount every month, a payment that eventually gets you down to zero. Borrow $1,000, 4%, 3 years, your payment's going to be $360.35. Find the interest paid in year 1. The borrower will owe interest upon the initial payment at the end of the first year. Interest to be paid in the first year can be found by multiplying the beginning balance by the interest rate. And there you go, 1,000 times 4 is $40. Find the principal repaid. Well, it's simple. You just take that payment less the interest. That's how much principal you paid. The ending balance, you just take the $1,000 minus the $320.35 to come that. And then you just keep going year by year. So we owe $660, the payment's $360, and the interest you can see is going down and down every year, and the principal payments are going up and up. And if we want to look at it like a table, you can see interest is a big part of your payments at the beginning and less as you go along. That's chapter 5. The big things I want you to take away from that. Use the spreadsheet to figure out the present value and the time value of money. Time value of money is hugely important. You can start investing now, small amounts, and it will pay you big dividends in the future because your money will make money on the dividends. You can make more money on dividends than you'll ever invest. Same thing goes when you buy stuff. If you get that fancy car and it's 10% interest rate versus 5% interest rate, that can mean a ton of money over the lifetime of the loan. All right, when we come back, next video will be Chapter 6, Interest Rates Overview. Thank you. Bye-bye.